The Vibrator Test software is a powerful tool for analyzing servo hydraulic vibrator performance, commonly utilized with the BirdDog Vibrator QC system. The software can also record independent magnetic mounted accelerometer data with the BirdDog system, enabling standalone testing without relying on the vibrator controller or its installed accelerometers. It supports a variety of industry-standard formats, such as SEG-Y and Sercel's local internal archive SEG-D vibrator signature files. The software generates detailed performance plots for review, which can be easily saved for final reporting. Additionally, Vibrator Test enables direct data access from Force 3 vibrator electronics, enhancing efficiency and accuracy in performance evaluation. After Vibrator Test is installed from the Seismic Source installer, a prompt will appear to activate a license when the software is opened. A license can be obtained in one of two ways. The first option is to log into the license server using credentials provided by Seismic Source to assign a license from an account. Alternatively, the system ID can be sent to Seismic Source to request a license file, which can then be loaded into the software. If a license is not activated, the prompt can be closed by clicking the X, allowing the software to be used in demo mode. To begin setting up the software, navigate to the Settings menu and select Project Settings. Enter a project name and click Create to set up the project. Previously saved project settings can be imported into the new project by selecting the Copy Settings from Current Project option. Once the project setup is complete, click the Open button to select a file containing vibrator data. For this example, a Force 3 vibrator similarity system DAT file from a single Force 3 controller will be used. After loading the file, press the Show Definitions icon. If the trace definitions are not automatically populated, manually enter the required details for each trace number. To view the loaded data, press the Traces button. This action will display all traces in the data file, providing a clear overview. Each trace will be labeled and shown graphically, enabling easy identification and detailed analysis. The overlay feature in Vibrator Test allows plots from multiple analyses to be compared by overlaying their results. This is particularly useful for evaluating the response of multiple vibrator units side by side. To use the overlay functionality, click the Add to Overlay button to include the desired plots in the comparison. Load in additional files if desired, then select Add to Overlay. The plots will be added to the Overlay Control dialog, where individual traces can be enabled or disabled by checking or unchecking their corresponding boxes. Additionally, clicking on a trace's color in the Overlay Control dialog highlights it for easier identification. To remove all overlays, click the Clear button. This action clears the current comparison, allowing for a fresh analysis setup. This feature is essential for identifying discrepancies or performance variations among different vibrator units, streamlining the comparison process. The Vibrator Test software requires two traces for analysis. The first trace, known as the reference trace, serves as the master reference trace sweep. The second trace, the analyzed trace VIBOut, is compared to the master reference trace. If necessary, the Invert Trace button can be used to invert the analyzed trace, changing the phase response by 180 degrees. Once the traces are selected, press the Process Data icon to update the plots. The top plot shows signal traces in the time domain. To configure the X-axis settings for all plots, adjustments can be made on the right side of the plot interface. Users can modify the sweep length to set the X-axis for time-based plots, or adjust the frequency limit for frequency-based plots. For individual plot adjustments, select the desired plot by pressing the Expand Plot icon. This will isolate the plot, showing it in a single view format. In the Zoom Settings dialog located on the top right corner of the plot, users can configure the X and Y axes. Fixed or whole range options are available for both axes. Choosing fixed allows manual entry of minimum and maximum values, while whole range displays the entire signal for the selected plot. Enabling the limits option will overlay threshold limit lines on the plots. After making adjustments, press Apply to update the graph. To return to the standard display, press the Collapse Plot icon. This process can be repeated for each graph to configure the X and Y axes as required. For the time variant spectral amplitude plot, an additional Z-axis setting is available in the main menu. Adjust the Z-axis minimum and maximum values, then press Apply to update the plot. As an alternative, users can right-click on a plot to access its settings directly. Users may adjust the report settings by navigating to the Settings menu and open the Project Settings tab. Here, users can select between the built-in editor or an external program like MS Word for report generation. Additional options include enabling a custom header. Here, users may add report details like client, job location, or custom graphics. Users may choose page orientation, either landscape or portrait, and decide whether the report should include results in Overlay View, which may overlay multiple records from one or multiple vibrators, individual view, or both, depending on needs. To create a report, click the Add to Report button. This feature will compile the currently displayed analysis into a new report or append it to an open report. For a comprehensive overview of multiple vibrator units, select the Group Report option. This generates a full report based on multiple analyses with a single click. Before running a group report, ensure the trace definitions for each vibrator unit have been set up in the Trace Definitions menu. The standard VIBTEST display presents results from 11 distinct analyses. The top plot illustrates the reference trace and analyzed trace in the time domain, enabling a direct comparison of their characteristics. The top left plot depicts the cross correlation, highlighting the phase relationship and any time offsets between the reference trace and the analyzed trace. The top middle plot is another cross correlation plot with the Y-axis represented in decibels. This view highlights the effects of vibrator distortion on the seismic data. For normal operation, correlation noise should remain below -60 decibels in the positive direction and less than -40 decibels in the negative direction, to avoid ghosting on the seismic record. The top right plot shows frequency versus time. This plot represents the sweep rate of the selected reference trace sweep. The middle left plot displays the amplitude spectrum of the analyzed trace, showing the energy distribution of the vibrator signal as a function of frequency. The middle center plot emphasizes the phase error of the analyzed trace relative to the reference trace. Time is represented on the x-axis, while phase in degrees is plotted on the y-axis. The middle right plot further elaborates on the phase error, but focuses on its behavior over frequency. The bottom left plot visualizes harmonic distortion. The y-axis represents distortion percentage, while the x-axis shows time. Options are available to display total harmonic distortion, THD, odd harmonics, even harmonics, or specific harmonics, such as the second, third, or fourth. The bottom middle plot provides the peak force versus time for the analyzed trace. When connected to a force 3 vibrator, the y-axis typically represents force in pounds. The bottom right plot displays fundamental force versus time, also in pounds, under similar conditions. The final plot at the bottom illustrates harmonic distortion through a time-variant spectral analysis. This process computes the amplitude spectrum of the analyzed trace across incremental time windows, identifying the fundamental frequency and its harmonics. Larger amplitudes denote stronger contributions from specific harmonics. The VSS summary report can be used to analyze all saved VSS data from multiple Force 3 vibrator controllers. This comprehensive report includes detailed graphs for phase, force, and distortion, as well as additional scatter plots showing critical values with time on the x-axis. The ASI and SIF files can also be used with the data collector software to include only production sweeps, omitting any test or void sweeps from the analysis. This ensures the final report focuses on meaningful production data. To begin, open one of the VSS files and set up the graphs. The VSS data can be either raw DAT files or in the SEG-Y format. To generate the report, select the VSS Summary Report option from the Report menu. Choose the directory containing the DAT or SEG-Y files. The process bar will indicate progress, and the final report will be generated automatically. The combined and zero time reports calculate the difference in zero time. It does this by determining time errors based on the encoder reference signal compared to the vibrator reference signal. The reported time error represents the average time error across the sweep. Large phase errors at low frequencies can result in significantly high time error values. The BirdDog 4 system may be used to record wireline tests. These records capture the reference signals from the encoder and vibrators, as well the vibrator's output signal. The BirdDog can record wireline tests from up to 5 vibrators simultaneously. When importing wireline test records, ensure that channel definitions are accurate. Proper scaling should be applied during the recording process. If necessary, scaling can also be adjusted in the trace definition dialog. For detailed scaling instructions, refer to the BirdDog documentation. Select Group Report to generate the reports. Thank you for watching. For more information on Seismic Source products, please visit our website at seismicsource.com.